Here we have a simple definite integral question, and let me give you a solution. If you use the power rule to integrate 1 over x squared, you get negative 1 over x, and then you have to plug in 1 and negative 1 here. 1 goes in here, so it's negative 1 over 1 minus, and then negative 1 goes in here, so it's negative 1 over negative 1. Negative 1 over 1 is just negative 1. Minus minus is plus, and dividing 1 by negative 1 also gives you negative 1. So what's this value? It's negative 2. Okay, what's wrong with this answer? Is there anything wrong with this? Okay, so
wouldn't it be 0?
No, it wouldn't be. Negative, negative, negative is negative. 3 negatives, negative. Okay. So the calculation itself is not wrong, but this is the wrong part. Okay. Let me explain why. To understand why, try to draw the graph of y equals to 1 over x squared. Well, since you guys wouldn't know what that looks like, let me just make a table of values. So if you plug in 1, 1 over 1 squared is 1. If you plug in 2, 1 over 2 squared is 1/4. If you plug in 1/2, then 1/2 squared is 1/4. 1 over 1/4 is 4. If you plug in 1/3, then it will be 9. And actually, it doesn't matter whether you plug in plus or minus, because you end up getting squared, right? So here's what you get if you draw the graph. Let's say here's 1, and that's 1. So 1 comma 1. And if you go to 2, it's 1/4, so it's here. At 1/2, it's like 1, 2, 3, 4, somewhere here. And then 1/3 it goes even higher, right? So it's like that. But then if you plug in the negative values, you get the same exact values. So there's a symmetry, which will create the graph that looks like that. Now, tell me the meaning of a definite integral. What geometric meaning does this definite integral have? Area under the curve, right? So it has the meaning of area under the curve. In our case, it's the area between negative 1 to 1 under the curve, so this is the area that we're looking for. Now, looking at the graph, what do you see that's very wrong with this answer?
You can't go out of it.
There's a top.
Okay, first of all, the shape looks strange, right? There's like, it goes up, right? It doesn't have like, what do you mean by the area under the curve when the thing goes to infinity, right? But that's actually secondary.
Area is positive in your answer.
Right, actually the more serious problem is that we know that the area is positive because the graph is over the x-axis, right? You only get negative area if the graph falls below the x-axis. Then this will be negative. If this is x-axis and if the graph falls below the x-axis, you get negative. But here the area is positive, but your integral value is negative 2. So there's something gravely wrong about this answer. It must be wrong. It can't happen. Okay? So that's the first takeaway from drawing the graph, but you guys are also right that there's something happening at 0. And that's when we talk about improper integrals. So what are improper integrals? Improper integrals are integrals that has infinity or negative infinity in the domain of integration or at some values of the integrand. So when when the function inside evaluates to infinity, so for example, when x goes to positive 0 or negative 0, this becomes infinity, right? So that's an improper integral. And if you have improper integral, these integrals must be handled with care. But what does that mean? Well, let me demonstrate what handled with care means in this specific example. And here's how we. So this one will be the wrong solution, and here's the correct solution. And it works like this. You have the integral from -1 to 1 of 1 over x squared dx. And you rewrite this as limit of two things. Limit, first of a going to 0 minus of integral from -1 to a of 1 over x squared dx, plus limit of b going to 0 plus of the integral from b to 1 of 1 over x squared dx. And graphically, this is what's happening. Here's a and here's b. And you're trying to integrate not from -1 to 1, but you're trying to integrate from -1 to a, which is a is slightly left of 0. So you have this area. And b to 1 will be this area. And there's a gap between them. And then you close this gap by sending a towards to 0 from the left. That's why I have a going to 0 minus. And sending b towards the 0 from the right. That's why I have b going to 0 plus. And that's how it should be interpreted. When you write this, this integral has the meaning that whenever there's an infinity there, you have to avoid that infinity and define that as a limit of some integrals. That's how you understand it. Does that make sense? Right? That's what I mean by handled with care. You have to reinterpret the integral as some limits. Okay. So what's the actual value then? Well, this one would be limit a going to 0 minus of -1 over x, and you plug in a and -1, whereas the other limit would be b going to 0 plus integral of 1 over x squared is -1 over x, and you plug in 1 and b. And then if you plug in a, that's -1 over a. When you plug in -1, you have to subtract -1 over -1. And you send a to 0 minus, plus limit b going to 0 plus. You plug in 1, that's -1 over 1. When you plug in b, you get minus -1 over b. Okay, let's try to figure out the limits one by one. If you divide -1 by a 0 minus, which is a negative number, do you get positive or negative? -1 divided by 0 minus. Positive or negative?
Positive.
Positive, right? This is negative, 0 minus is negative, negative divided by negative is positive. But if you divide 1 by a very, very small number, it becomes really, really big, right? So this limit would be positive infinity. So this is going to be positive infinity, minus, 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 that's still -1. This will be -1. And then what's that? Negative, negative, 0 plus. So that's plus 1 over 0 plus, but 1 divided by 0 plus would be?
Negative.
Positive. No, plus, plus, okay? 1 divided by 0 plus would be positive infinity, because they're both positive. So if you have infinity plus infinity, no doubt it's going to be positive infinity. So that's the correct answer. Yes? You have a question?